Hello class, and welcome to today's algebra lesson, which is about exponential growth and decay. By the end of today's lesson, you will be able to write and solve exponential growth and decay functions, as well as compound interest functions. So we're going to start with exponential growth. This is a specific type of function that is used to predict things that are increasing over time exponentially. This formula that we have here, y equals a is your initial value, so whatever the problem gives you as a start, that a is your initial value. The 1 stands for 100%, but it is written in its decimal form. The r stands for the rate or the percent, and it must be written in its decimal form. Remember, to get from a percent to a decimal, so for example 25%, we move that decimal over twice, giving us 0.25. So every time you go from percent to decimal, the decimal moves 2 places left. And then the t stands for the amount of time that is occurring. You want to make sure if it says, if it's giving you a rate of 7% per year, then that time needs to be in years. If it says 7% per month, then that time needs to be in month. So whatever the rate is being measured in, the time label needs to match that. So for example, a radio station is having a contest and a prize starts as a $100 gift card. So notice we've got a starting initial value here. Every day the DJ announces a name and the winner has 15 minutes to call to claim their prize. Well, that's telling us more about the scenario. It's not actually helping us write the equation. If no one calls, the prize increases by 2.5%. So that tells us that we are going up by 2.5%. Now, it says this happens every day, so our time needs to be on a daily basis. Write an equation for the value of the gift card after X days with no winner, and then determine the value after 10 days. So the first thing it asks us to do is write the equation. So I'm going to start with y equals, and then I've got that prize starting at $100. And then I've got parentheses. I always start with 1 to stand for 100%. And then I'm adding on 0.25. So I move that decimal once twice, which gives me 0.025 as 2.5% as a decimal. And then right now it just wants us to do X days. So the first thing it asks you for is to write that general equation. The next thing that you need to do is then answer the question. So it asks us for what happens after 100 days. So it's our same equation with, not 100 days, with 10 days. When you plug this into the calculator, you want to plug this in all at once. We don't want to do any rounding in the middle. So you would type this into your calculator as 100, parentheses, 1 plus 0.25. And then remember, we use that caret button, so that little upside down V. And then you would type into the 10th power. And when you do that, after rounding, you get $128.01. So that is our prize value after 10 days. Go ahead and try this one on your own. First, just writing the equation. So our equation, we've got our starting value plus our percent as a decimal to the x power. Now go ahead and predict the cost of tuition in 2022. So we should plug in 12 as our exponent because we started in 2010 and we are at 2022. So that is 12 years and our tuition is $31,741.76 after we do our rounding. Exponential decay is almost the same thing, but this formula is now for when things are decreasing or going down. Same meanings for our formulas here. The A is still our initial value. That's still the amount that we start with. That 1 still stands for 100%. The R still stands for our rate and still must be written in decimal form. And T is still our time and must have a matching label to whatever the rate is. So a fully inflated child's raft for a pool is losing 6.6% of its air every day. So losing is indicating that it's decay, 6.6% of its air every day. So we should be doing time in days. The raft originally contained 4,500 cubic inches of air. So that is our original value that we have. Write an equation to represent the loss of air after X days, then calculate the amount of air left after 7 days. So once again, we start with just our general equation. So Y equals 4,500 times 1 to stand for 100% plus 0.066, that percent turned into a decimal, to the X power. Then it is asking us to calculate after 7 days. So I'm going to take that same equation and I'm going to plug the exponent in as 7. When I do that calculations, after I round, I end up with 2,790.23 cubic inches of air left in the raft. So you always want to round to 2 decimal places unless the problem indicates otherwise. Go ahead and try this one on your own. First, just writing the equation. So as you write your equation, you've got your initial value, your 1, subtracting off your percent, moving that decimal over twice, and then plugging in your X as your exponent. Now go ahead and calculate the population in 2030. So we plug in an exponent of 15 because it has been 15 years in this problem. And we round this one to the whole number. You cannot have a decimal of a person. So we've got approximately 81,006 people in this county. The last formula we are looking at is compound interest. This is a specific type of exponential function that deals with money. We talked about a little bit last year. Interest is something you are earning or paying on a loan or an investment. It's a little extra money that you get either for investing in something or a little extra money that you have to pay for borrowing something. The formula is slightly changed for this particular problem. P, which stands for principal, that's why it's P, that is an initial amount of money. So we still have our initial amount as our front number outside the parentheses. The 1 is still there. We have 100% still. The R is still part of our equation. That is still our rate written in decimal form. This new piece, this N, which you see both inside the parentheses and in the exponent, is going to stand for number of times compounded. So what that means is as they are calculating interest, it's going to happen at different intervals throughout the year. If it happens annually, it happens once. So your N would be 1. If it happens biannually or semi-annually, both of those have the same, that same prefix means the same thing, and that is twice per year. If it happens quarterly, that is going to be 4 times per year, and monthly is going to be 12 times per year. It could give you other specific times, so if it specifically said it is compounded 3 times in a year, you would use 3 for N. So N can be any number. These numbers down here are just the most common that are used when compounding interest. So Macy's parents invested $14,000 at 6% per year compounded monthly. So we've got our initial value, that P, we've got our percent, that rate, which we're going to have to turn into a decimal, and then it says it is compounded monthly, which is going to give us an N value of 12. So my initial equation here is y is equal to 14,000 times 1 plus r, which is going to be 0.06 over n, which is 12. And then we have, for this particular problem, 10 years and our n value of 12, so 12 times 10 as the exponent. Now, when you are typing this in the calculator, if you typed this in exactly as written, this exponent would not calculate correctly. Because there is multiplication in your exponent, you want to solve this before you plug it into the calculator. So what you should actually plug into your calculator is 14,000 parentheses 1 plus 0.06 divided by 12, and then to the 120th power. You want to solve this exponent before you plug it into the calculator. Once you do that, you are going to get an answer of $25,471.55. So that is what we get when we plug our answer into the calculator. Go ahead and try this one on your own, solving for how much the investment will be after our time frame. In this case, we end up with $646.48 after the 22 years. The last piece we want to be able to do is to compare different types of investment. Generally, what you are comparing against is an annual investment. So something that just happens once a year, and looking at what the difference would be if you compounded more than one time per year. So when you do this, I like to start with the compounded value first. So I'm going to do my calculation for compound first. When I do that, I've got my principal of $5,000, my annual interest of 5.25%, so in the parentheses, 1 plus 0.0525. And then I have number of interest periods. That tells me how often it is compounding. This is going to occur 3 times. And then I've got my 3 times the 12 years in my exponent. Remember, solve that exponent to 36 before you plug it into the calculator. And when you do that, you get an answer of $9,337.04. Then you want to go through and do the comparison for if it just happens annually. So if it only happens once per year. That is going to give us $5,000. And then 1 plus, my n value is now 1. So I don't have to divide anymore in my problem, because 0.0525 divided by 1 is just going to be 1. I don't have to multiply in my exponent anymore, because 1 times 12 is just going to equal 12. So you can go ahead and plug that into your calculator, and you are going to get a value of $9,239.22. The last part it asks us to do is to compare. So in order to do that, I am going to subtract these two values, and I end up with $97.82. So what that means is when you compound three times per year, you earn an extra $97.82 in interest. So we have that extra piece that we earn. Go ahead and try this one on your own. First, calculate your compounded value. So with our compounded quarterly, we end up with $14,939.26. Now go ahead and find the annual value. If it is just annual, it is $14,707.67. Finally, go ahead and compare them. So we end up with $231.59 more when compounded quarterly. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.